We're solving problem 11 from the 2023 AIME 2. Find the number of collections of 16 distinct subsets of this set with the property that for any two subsets x and y in the collection, this is true. Now for this problem, we can set A as a subset of this, or no, we can set A as this, and a collection of the subsets as S. So basically what we can do, we can just start considering cases. So we have our first case, we call it case 1. Now this problem just relies on casework and just counting, right? So for case 1, we are going to have sets of 3s or higher. And this, we can basically like evaluate through a short process that this yields us only one way. Now, case 2 is where it gets a little more interesting because we have sets of 2 or higher. If we have one set of 2 where there's 2 in the set, then that just gives us then we can start counting. So if there's just the one set of 2, there's 10 ways to choose both the numbers. So we have the 10. And then we can just keep counting up at this point. So then we have 2 sets of 2. And then for 2 sets of 2, well, what we can do here for the 2 sets of 2 is, well, there's a lot more cases to consider. So we're going to have the 5 from here, and then we're going to have to multiply it by 6 to get 30. And this is 30 ways to do that. Now, for 3 sets of 2, I don't know why I keep on drawing arrows, but for 3 sets of 2, we can again keep counting this time. To evaluate it, we have either 5 times 4 equals 20 or 5 choose 2 equals 10. But since both of these are different cases, we sum those up and we get 30. And then we have 4 sets of 2. And this just yields 5 times 1 equals 5. All of these in case 2 sum to 75. And then case 3, where we just have 1s. So if we just have one set of 1, right, we can call it like this, just this, but then it has to be in all of S. So if we just have one set of 1, we we'll just have basically 5 times 1 from 2 to the power 4 minus 1 equals 15. So there's 5 ways to do this. So then we have our sum, which is all of these numbers. So we have 1 plus 75 plus 5 equals 81. And that is our answer for this problem.